3.72 gigabytes. That's all the video memory it took to run the largest OpenAI model on Earth, Kimi K3, 2.8 trillion parameters on one single graphics card, not a cluster. One card using less memory than a Chrome tab habit. 26,000 developers start the trick behind this, and I spent the week checking the math, and the math is real. But sitting in the same release notes is a second number that almost nobody quotes, and it completely changes what this tool is actually for. By the end of this video, you'll know which of the 4 headline claims are true, and one of them is not. You'll know the one sentence of physics that explains the whole trick, and you'll know the exact situation where this beats every other option in AI. Every receipt I show you is real, and I'll show you where each one lives. Here's the promise, exactly as the repo states it. AirLLM, 70 billion parameter models on a 4 gigabyte GPU. Llama 405B on 8 gigabytes. DeepSeek V3, 671 billion parameters on about 12. And as of 5 days ago, Kimi K3, 2.8 trillion parameters in under 4 gigabytes of VRAM. No cluster, no API bill, one line of Python. This pitch first went viral back in November 2023. The package has been downloaded over 265,000 times, and the star count sits at 26,400. Now, 2 weeks ago on this channel, I ranked the coding models that fit on a normal computer, and the honest ceiling was mid-tier cloud quality. This repo claims that ceiling is fake, that the biggest models on the planet already run on the card in your old gaming laptop. So I did what, as far as I can tell, nobody on the public internet has done. I audited every headline number against the actual code, the actual model files, and every receipt buried in 3 years of the issue tracker. First, the trick itself, because it's genuinely beautiful. A 70 billion parameter model is about 141 gigabytes of weights. Your GPU holds 4. AirLLM's move is that it never loads the model. It builds an empty skeleton of the network. And at runtime, it streams one layer at a time from your SSD into the GPU. Compute the layer, free it, stream the next one. Llama 70B is 80 layers at 1.71 gigabytes each, plus an output layer at 2.1. So at any instant, the GPU is holding roughly 2 gigabytes of weights plus a sliver of context memory. I checked this module by module against the real model files, and peak usage lands around 3.5 gigabytes. So the 4 gigabyte claim is not marketing. It's real at full precision with no quantization. And here is the one sentence that explains everything else in this video. Your VRAM only needs to fit the biggest single layer, but every single token has to walk through the entire model. So let's put all 4 headline claims on trial with the model files as evidence. Claim 1, 70B on 4 gigabytes. Verified, full precision, the arithmetic holds with room to spare. Claim 2, 405B on 8 gigabytes. The math works at short context, but here's the asterisk. The example notebook, the repo links for this, quietly loads a pre-quantized 4-bit version of the model, which is exactly the thing the headline says you don't need. Partial credit. Claim 3, DeepSeek V3 on about 12 gigabytes. True, but only because DeepSeek ships its own weights in 8-bit. A single layer of that model is 11.5 gigabytes, so it fits with almost zero room left. And claim 4, Quen 3 to 35B on, quote, about 3 gigabytes. I could not make that number work. By my arithmetic, a layer of that model is 5 gigabytes. And for this model, the code streams whole layers. Expect 5 to 5.5. One claim fails the audit. Now for the other half of that sentence from earlier. Every token walks through the entire model, and the entire model lives on your disk. Nothing can be cached between tokens because the model is dozens of times bigger than your VRAM. So the speed limit is brutally simple. Model size divided by disk speed. 141 gigabytes across a fast NVMe drive, at 3.5 gigabytes per second is 40 seconds per token. And that's the best case physics floor, not the typical experience. The issue tracker tells you the typical experience. There is a real issue still open, whose actual title is taking about 40 minutes to generate one sentence. Is this speed normal? That user was on an RTX 3090. When the 405B version hit Reddit, the top comment on the whole thread was 4 words: how slow is it? And the most upvoted reply was a roast. Quote, it has the advantage of being slower than CPU in most situations. Even the author's own 2023 launch article contains the confession, buried near the bottom. Not very suitable for interactive scenarios like chatbots. If this audit is useful, hit subscribe because it's free. And to back the work, hit join here or the supporter button on Facebook. Now, the untold part of the story. Because here's where it gets genuinely interesting. For all of 2025, this famous repo was essentially dead. 3 commits the entire year. Then in June 2026, it suddenly came back to life. Years of old issues closed in one 5-minute sweep, sponsor links appearing at the top of the README. And on June 21st, someone filed the issue that this whole video hangs on. Its title, Headline VRAM, and performance claims lack reproducible verification. It documents, file by file, that no headline number in this project's history ever shipped with a benchmark, a log, or a memory capture. That issue has never received a reply. But 5 weeks later, something remarkable happened. The maintainer, an ex-Airbnb lead, shipped Kimi K3 support, and for the first time in the project's 3-year history, he published a measured benchmark. Peak VRAM, 3.72 gigabytes on a real named GPU. And in the same table, the number from the start of this video finally gets its partner. Generation speed, 292 seconds per token. On Medium, he wrote, and readers made it the top highlight of the article. This is not fast. Roughly 5 minutes per token. The bottleneck is not compute, it is disk. 32 months after the word unbelievable, the fine print finally got printed. For completeness, that pull request was opened and merged by the same person 4 minutes apart. No human review, with the words made with cursor at the bottom. And the verification issue is still open today. Now the twist that turns this from a slow party trick into something genuinely clever. Kimi K3 is a mixture of experts model. Every layer holds hundreds of small expert networks, 896 of them, but each token only visits 16. So AirLLM's K3 code streams, individual experts instead of whole layers. Run those numbers and something wild falls out. One token through the 2.8 trillion parameter model only pulls about 83 gigabytes off the disk. That is less data than a dense 70B model moves for the same token. Per token, the largest open model on Earth is cheaper to stream than Llama 70B parameter count. Just stop being the spec that matters. Bytes per token is the new spec. Before you get excited, the entry fee. The download is 1.56 terabytes, which is about 35 hours on a 100 megabit connection. You need at least a 2 terabyte drive, a CUDA 12 setup with flash attention, and one more warning. The README says max just work, but the standard quick start example currently crashes on Apple Silicon. The bug is open, and the community fix was closed without being merged. One receipt in that tracker matters more than all the others because it hands you the control dial. A user ran the same 32 billion parameter model on the same GPU twice. From a spinning hard drive, it was just above 2 minutes per token. From a RAM disk, 13 seconds per token. Same model, same graphics card, roughly 10 times faster, and the only thing that changed was the disk. That is the whole game with this tool. Your storage is effectively your GPU. NVMe instead of SATA, Gen 4 instead of Gen 3, a RAM disk if you have memory to spare. And batch your prompts. Because the layers stream once per pass. Stack 50 prompts into one batch and you split that disk cost 50 ways. So, who is this actually for? The best answer in the entire tracker came from a user the maintainer brushed off, a doctor, a psychiatrist in training in France who also happens to code. Patient data legally cannot leave his machines. So, cloud AI is off the table no matter how good it gets. He already builds tools that run entirely on the patient's device. And in the issue, he described his dream setup: slow but huge local models, turning scans of paper patient surveys into research data. Overnight, no internet, nothing ever leaves the room. For him, 5 minutes per token is not a bug because the privacy is the entire product. His issue was closed with the note, reads as a discussion. But the community's defense of this tool says exactly the same thing he did. Quote, if the trade off is only time, this is amazing for workloads where jobs are queued. And that is the honest shape of AirLLM. It's a batch machine. Documents analyzed while you sleep on a model you could never afford to host for free in total privacy. It is not and was never going to be your chatbot. The final ledger. Screenshot this frame if you keep nothing else. Verified. 70B in 4 gigabytes. Full precision. Real. Kimi K3. 2.8 trillion parameters in 3.72 gigabytes. Real, measured, and published by the author himself. Asterisk. 405B wants short context, and the only worked example is 4-bit. Asterisk. DeepSeek fits in 12 only because it ships in 8-bit. Failed. The 3 gigabyte Quen claim, my arithmetic says 5. And the silence. The README still contains no tokens per second number. Anywhere, today. The law underneath all of it fits in 2 lines. VRAM equals your biggest layer. Time equals the whole model divided by your disk. So here's your decision rule. If you want an assistant that answers right now, run models that actually fit in memory. And my tier list video covers exactly which one for your machine. But if you need the biggest brain available for private, overnight, batch work, this is the only free game in town. And now you know its real price. Patience. Real talk. 90% of you watching haven't subscribed. On Facebook, subscribe is the supporter button. That is what keeps the lights on here. On YouTube, it's free and it tells the algorithm to send you more. Subscribe to support us. I compiled this whole investigation into the giant model playbook. Every claim with its verdict and the arithmetic behind it. The real VRAM, disk, and download table for all 5 giant models. The disk speed dial with the RAM disk trick. The batching playbook. And a 1-page decision tree that tells you whether your job is a fits in memory job or a giant model overnight job. It's completely free. Comment the word giant and my bot sends you the link. Or grab it directly at hyperautomationlabs.co/free/giant. If you're getting started with AI agents, my 4 beginner guides are linked below as well. Follow on Instagram and Facebook for the daily clips. And I'll see you in the next audit.